Alright, let's look at the homework 4, problem number 1. Alright, so let's solve this first order linear equation. Alright, so first thing I would do is I would like to get rid of x squared plus 4. So I'm going to divide the equation through by x squared plus 4. Alright, so we get dy over dx, and then you have plus 3x over x squared plus 4 y is equal to x over x squared plus 4. Right? So we can let's see. Integrating factor would be rho of x is equal to e to the integral of p of x. So in this case, this is the p of x right here. This is our p of x. So we can just integrate 3x over x squared plus 4 with respect to x. Alright, and then I'm going to actually, let's see, I'm going to put 3 outside of the integral. And I would like to have 2x, so I'm going to divide through by 2. Alright, and x squared plus 4x for dx. Alright, the reason why I did that is that since if you remember, if you look at the antiderivative of g prime of x over g of x with respect to x is natural log of absolute value of g of x plus some constant c. So I would like to have exact derivative of the denominator there, so which is 2x. So I pulled 3 out and I put 2 since I wanted to have a 2. So divide through by 2 so we don't change anything. All right. So this way we have e to the 3 halves natural log of we don't need absolute value sign anything x squared plus 4, and x plus 4 is not never negative anyway. Or 0. Alright, so you can put 3 halves as a power here. Then you can cancel exponential function and log function. So you're going to have x squared plus 4 raised to the 3 halves power. Alright, then we can just multiply the equation through by the integrating factor, so multiply by rho of x. We get, I'm going to put dy over dx first, times x squared plus 4 to the 3 halves power, right, plus y times, and this guy, integrating factor times p of x would be, let's see, 3x, and then you have x squared plus 4 quantity raised to the 1 cancel out, so 1 half power. Alright, then is equal to x over x squared plus 4 times that would be x times x squared plus 4 to the 1 half power. Alright, so you can see that this can be rewritten as y times quantity x plus 4 to the 3 halves power prime. Alright, and is equal to, same right hand side, x squared plus 4 to the 1 half power. right? So we can integrate both sides with respect to x. We get the y times x squared plus 4 to the 3/2 power is equal to, right? So we have integral x times x squared plus 4 1/2 power dx. All right. So here you can use a substitution, or since derivative of x squared plus 4 is 2x, so I'm going to actually put 2 here, and then I'm going to put 1/2 in front. Right? Then we're going to look at it as, so this is going to be, alright, so 1/2 is still there. Alright, antiderivative of 2x times x squared plus 4 to the 1/2 power. So this is by general power rule. Add 1 to the power, so you have x squared plus 4 to the 3/2 power. Divide by 3/2 is same thing as multiply by 2/3. And then plus some constant c. Alright, so you can cancel 2 on top and 2 on the bottom. Right, and also we need to isolate y, so I'm going to divide through or multiply by, divide through by x squared plus 4 to the 3/2 power. Right, then you can see that the y is going to be equal to, alright, so you're going to have, let's see, 1/3, right, and plus, and let's see, this is going to be c divided by that, so I'm going to just write it as a c over x squared plus 4 raised to the 3/2 power. Right, then what you can do is you can use this guy to find the c value. Right, I'll let you finish there. So use initial value condition, f of y of 0 is equal to 1, then find c, and you find that the solution is given here. All right, that's it. I hope that this will get you guys going.